next we're going to calculate some really basic shear stress examples. In shear stress example, or in the shear stress is pretty similar to normal stress, but with shear stress the unit is the same. So this shear stress unit is in megapascals, but the symbol which we use for shear stress is Greek letter tau. And when we calculate shear stress, we divide the shear force with the cross-section area in which the shear force is affecting. Here we have a really basic example. We have 3 pieces of wood, and they are glued together. We are asked to calculate what is the required height of the glue area. So the glue area is from here to here on both sides, so that the maximum shear stress is 10 megapascals. So what is the required height for the glue area to keep the stress below the required 10 megapascals? So in this example, it's also possible to do the free body diagram. So let's do the free body diagram, FBD. So if we take a look from the side here, we have the center piece of wood, like so. There's force, 120 kilonewtons, pushing from here. And then in the sides, we have the glue area. So the glue is in here, like that. And in there, we have a force that is against the 120 kilonewtons. And since the glue is on both sides, we have force on both sides, and we name this V, so-called shear force. Okay, so these V's, they are on these sides from here and here, and they are supporting this centerpiece. So now we can easily calculate with the basic equation that sum of all forces in vertical direction has to be equal to 0, and hence 2 times V, so V from left and right side, minus 120 kilonewtons equals 0, and this is our equation number 1. And from equation number 1, in this case we don't need any other equation because all the forces are in vertical direction. And from equation number 1 we can solve that V is 120 kilonewtons divided by 2, it is 60 kilonewtons, like so. So now in this example, I will try to draw the kind of like the 3D presentation of the case here. So we have this wooden piece here, like this. And last like this. Like that. Like so. And now on the side in here, we have the glue area. So here is this is the area which is glued, and in here we have the force is V. So this is the glue area, and it's similar on both sides. And from top we are pushing with the force of 120 kilonewtons from here. So now from this drawing, this is the length A, we need to solve that one, and this is the dimension which was given. It's the dimension B, which is 150 millimeters. So in this example, the 1V is affecting on this side, and now the formula for shear force was shear stress was tau equals to shear force divided by cross section area, and now in this example the maximum shear force was 10 megapascals, 10 newtons per millimeters squared, equals to shear force, which was V, so 60,000 newtons, divided by the cross-section area, which will be 150 millimeters times A. And from there we can solve what is A. A equals to 60,000 newtons divided by 150 millimeters multiplied by 10 newtons per millimeter squared. One of the millimeters subtracted away, newtons subtracted away, and we are left with value for A, which will be 40 millimeters. So that was a basic example on how to calculate shear on this kind of case. Okay. That's it.